Okay, very good. So thanks again for joining us today, mates. It's a pleasure to have Leslie Marx presenting joint work with Simon Lorcher. Leslie is no strange to these lands. She usually visits Australia, so we're really happy to have her in this format for this year. She's going to talk about incomplete information bargaining with applications to mergers, investment, and general and vertical integration. Leslie, the floor is yours.
Thank you very much, and thank you for the invitation. And I'm very happy to have the opportunity to present here, but I'm also very sad not to be actually there. An opportunity to present in person, which I suppose will come one of these days. This is joint work with Simon Lorcher, who you all know at the University of Melbourne. Bargaining has come to the forefront in industrial organization and plays a prominent role in recent antitrust cases, including in healthcare, telecom, media markets, intellectual property. And a common practice in modeling bargaining is to assume that agents have complete information. Typical approaches based on Nash or Shapley, they would assume efficient bilateral bargaining. And these approaches have downsides in that bargaining loses much of its interest when information is complete, as noted by Schulenberg and Tirole, and shifts bargaining power only affect the distribution of surplus and not the size of total surplus in those models. That said, the popularity of complete information approaches to bargaining is in no small part due to perceived challenges with incomplete information bargaining, including the lack of tractability of extensive form representations, dependence of bargaining outcomes on higher order beliefs, and common knowledge of type distributions. Nevertheless, there is a consensus in IO that there is a need to contend seriously with incomplete information. Incomplete information models have a number of desirable properties, including that first-degree price discrimination is not possible because of incentive compatibility, and so it doesn't need to be ruled out by assumption. That uniform pricing is optimal for monopoly-facing concave revenue, so uniform pricing comes through as a conclusion rather than an assumption, and there is a trade-off between social surplus and profit, which is at the heart of much of IO. In this paper, we're going to apply an incomplete information approach to bargaining in a setup with multiple buyers and multiple suppliers. More specifically, we're going to develop an incomplete information bargaining framework and sidestep the lack of tractability of extensive form gains by taking what you might think of as an as-if approach, in which allocations and transfers are on the Pareto frontier, achievable through mediated mechanisms. We're going to think of there as being a market mechanism that behaves for a given bargaining rate as if it were maximizing the weighted sum of agent surplus, where the weights are their bargaining rates, subject to incentive compatibility, individual rationality, and no deficit. Our model is going to encompass, as special cases, the bilateral bargaining model of Myers and Satterthwaite, and we'll talk more about that. The bilateral bargaining model with bargaining weights of Williams, 1987, and the multilateral bargaining model of Gressick and Satterthwaite. And we're going to apply this framework to analyze several longstanding questions in antitrust. Some key features. Looking at vertical integration, we find there's no basis for a presumption that vertical integration increases social surplus because efficiency is endogenous, and vertical integration, as we'll see, can either create or resolve a Myers and Satterthwaite problem. With respect to equalization of bargaining weights, changes in bargaining weights and market structures have direct effects on social surplus that allows us to analyze policies or changes that you might expect to equalize bargaining power in the market, and allow us to talk about and make sense of the countervailing power defense of mergers and joint ventures. And with respect to investment incentives, we'll see that efficient bargaining implies efficient investment, and that private information protects agents from holdup. Okay, my plan now is just to say a little bit more about each of these blue topics here, and then talk about the model on this side. Okay. Any questions so far? Great. So I'm going to go just a little bit more on each of these for some motivation before we launch into the model. With respect to vertical integration, there was a recent 2020 update to the US Department of Justice and Federal Trade Commission vertical merger guidelines that said vertical mergers often benefit consumers through the elimination of double marginalization, which tends to lessen the risks of competitive harm. Vertical mergers combine complementary economic functions and eliminate contracting frictions, and therefore have the capacity to create a range of potentially cognizable efficiencies that benefit competition and consumers. So overall, the guidelines had a kind of favorable view of vertical mergers, although they did recognize that vertical mergers are not invariably innocuous. But this way of thinking largely ignores the potential for adverse efficiency effects of vertical integration due to its effects on the bargaining process. And so we'll see how that can play out. On equalization of bargaining weights, Galbraith in 1954 saw the neutralization of one position of power by another position of power as a mitigant of economic power of substantial and perhaps central importance. Modeling this notion of balancing power has proved challenging. Stigler lamented the lack of explanation for why bilateral oligopoly should in general eliminate and not merely redistribute monopoly gains. And Sider and the new Palgrave said noted that it's difficult to model bilateral monopoly or oligopoly, and there exists no single canonical model. Nevertheless, this idea has popular appeal and has been influential in antitrust. As a couple of examples, there are two OECD reports that talk about whether there might be a role for collective negotiation and group boycotts by merchants, by shops, stores, in order to counterbalance the market power by Visa and MasterCard. So wanting this balancing bargaining power. And then in a DOJ and FTC report, they talk about the potential benefits for allowing physician network joint ventures, so allowing physicians to come together to balance the power of the big insurers. So our framework is going to open scope for countervailing power defenses and will allow us to talk about these countervailing power arguments.
Leslie, could I ask you a question?
Please.
In the last 2 points that you mentioned, these are examples of horizontal mergers, right? So the physicians, for example, getting together to act as a counterweight. So you're also talking about horizontal mergers and not just vertical mergers? Yeah,
we'll talk about horizontal too. Yeah. So we'll talk about horizontal mergers, vertical mergers. We'll have buyers and suppliers. Buyers on one side of the market, suppliers on the other. So we'll be able to think about mergers among suppliers, mergers among buyers, and also a vertical merger, combination of a buyer and a supplier.
What do you refer to? I mean, I guess you're going to explain that more carefully later on, but what do you mean by vertical merger? Should I assume there is an upstream market that provides suppliers with, or these suppliers merge with a buyer, a supplier merges with a buyer?
Yeah, a supplier merged with a buyer.
Okay, cool, thanks.
That's how we'll think about it, yeah. On investment incentives, the Incomplete Information Bargaining Framework has the feature that when agents make non-contractable, non-observable investments that improve their own type distributions, then efficient incomplete bargaining is going to imply efficient equilibrium investments. And this sheds new light on ongoing debates on the interaction between market structure and investments, and is really going to epitomize the contrast between this incomplete information framework and complete information models with efficient bargaining, because in the complete information models with efficient bargaining, you're going to get inefficient investment because of holdup. But with incomplete information, incentive compatibility is going to protect agents from holdup. And if bargaining is efficient, we'll perfectly align investment incentives with the planner's objectives, so you get efficient investment. So to give an overview, we're going to reinterpret the Meyerson-Satterthwaite setup as a bilateral monopoly problem and extend it to allow bargaining weights and multiple agents on both sides of the market. We'll be able to capture the key economic trade-off between rent extraction and social surplus. And without resolving issues of common knowledge assumptions, it seems fair to deflect criticism of incomplete information bargaining models based on these concerns, because common knowledge of distributions is at least weaker than assuming common knowledge of the realized values and costs as you would in a complete information model. And our market mechanism is going to have a dominant strategy implementation, and so higher order beliefs are not going to play a role for us. Right. That was by way of introduction. Let me know if there are any questions. I'm going to go ahead and talk about the setup. Our setup has a set NS of NS suppliers, so some number of suppliers, and B buyers. Each of the suppliers is going to draw a constant marginal cost for up to some number of units independently from a distribution. So supplier J will draw from distribution GJ with support C lower bar to C upper bar. Each buyer I is going to draw a constant marginal value for up to some number of units independently from a distribution Fi with support V lower bar to V upper bar. We of course we're going to assume that gains from trade are possible. So we'll assume that the C lower bar is less than V upper bar. Quasi-linear utility, the types are agents' own private information, and the distributions and capacities will be common knowledge. We'll assume that supplier J has an increasing virtual value function, which we're going to denote by gamma, and that buyer I has an increasing virtual value function, which we'll denote by phi. Okay, that's the setup. Let me give an illustration, which I think will show some of the key issues that are key features of the model. Let's start to get warmed up with a Meyerson-Satterthwaite or Williams model of bilateral trade. So we have one buyer, one supplier. We're going to have multiple buyers and multiple suppliers, but let's start with one of each. The second best would be to maximize social surplus, subject to incentive compatibility, individual rationality, and no deficit. The first best would be to maximize social surplus ex post without the no deficit constraint. And we know from Meyerson-Satterthwaite that the first best is possible with no deficit if and only if C upper bar is less than or equal to V lower bar. So if and only if we have non-overlapping supports, and that the first best requires a deficit otherwise. So if you have overlapping supports, in order to avoid a deficit, you're going to have to sacrifice efficiency. We can look at some numbers here. If we assume the types are drawn from the uniform distribution on 0, 1, in that case, the buyer optimal mechanism would be for a buyer with value V to make a take or to leave it offer to the supplier of V over 2. And that gives a payoff to the buyer of 1 over 12 and to the supplier of 1 over 24. So this graph has supplier payoffs on the horizontal axis and buyer payoffs on the vertical. So that's this dot here. The corresponding supplier optimal mechanism gives the reverse payoffs of 112 to the supplier and 1 over 24 to the buyer. And of course, you could have intermediate bargaining power. For example, you could have randomized take or to leave it offers, and then you could achieve any of the payoffs that are in between those 2 points. But we know from Meyerson and Satterthwaite that you can do better, that there exists an incentive compatible, individually rational, no deficit mechanism that has payoffs for the agents of 9 over 128, which is this dot out here. And Williams shows us that you can actually trace out the whole frontier, the Pareto frontier, with a K double auction as you vary K from 0 to 1. So in the K double auction, the buyer and supplier both submit bids. There's trade if and only if the buyer's bid is greater than the supplier's bid, and trade happens at the price that is K times the buyer's bid plus 1 minus K times the supplier's bid. So it happens when K is a half, it happens at the midpoint. of their 2 bits. And k equal to 1 corresponds to the buyer optimal mechanism, k equal to 0 to the supplier optimal mechanism. And the thing to notice here is that as you go from, say, k equal to 1/2 to k equal to 1, the mechanism starts to favor the buyer more and more. That increases the buyer's payoff, reduces the supplier's payoff, but it also reduces the total payoff. So you pull away from the second best frontier here, which is achieved with equal bargaining rates. And one way to think about this is just if you think about an auction with one-sided private information, the way the auctioneer is going to maximize their expected payoff is by imposing a reserve. And that reserve price is going to result in there being, when it's binding, no trade with some positive probability. So it reduces your social surplus. So the way you skew the mechanism, when you do skew the mechanism towards one agent versus another, there's a cost in terms of the social surplus. So we're going to reinterpret Meyerson's Satterthwaite, take that basic model as a bilateral monopoly with bargaining weights, as does Williams, and augment it to allow multiple buyers, multiple suppliers, and multi-unit demand and supply. But it's still going to be the case in our setup that maximizing one trader's surplus is going to harm the other traders and also reduce social surplus relative to the second best or first best.
So, okay, can I ask a quick clarification question? So here, does it matter if IC is in dominant strategy or in bias Nash?
It's not gonna matter for us. We have independent private values, single dimensional types, linear utilities. So there'll be a dominant strategy implementation. Yeah, good. So here, our incomplete information bargaining model, we're going to assume there are bargaining weights. So it'll be this vector W will have a weight for each of the agents. All of those weights are going to be between 0 and 1. At least one of them is not 0. And we'll define weighted welfare to be each buyer's weight times the buyer's surplus plus each supplier's weight times the supplier's surplus. That'll be our weighted welfare. And then our bargaining mechanism, our incomplete bargaining mechanism, is going to be the mechanism that maximizes expected weighted welfare subject to incentive compatibility, individual rationality, and no deficit. Now, I think it's useful to do a little math here. I think it's helpful, so I'm just going to click this button here. So we know by incentive compatibility that buyer I's expected payment up to a constant is equal to the expected value of the virtual value function times the agent's allocation, and that seller J's expected payment from the mechanism is up to a constant the expected value of its virtual cost times its allocation. And that lets us write the Lagrangian for the problem of maximizing weighted welfare subject to the no deficit constraint in this form. So we have the buyer's surplus. So the buyer gets its value minus its virtual value, that's its payment it's going to make to the mechanism times the allocation. And the seller's surplus is its virtual cost minus its cost. And then the budget surplus to the mechanism is the payments phi from buyers minus payments to the suppliers, and then rho here is our Lagrange multiplier. So I'm going to take this Lagrangian and just rewrite it, emphasizing the allocations, the Q's now, and notice that for any given value of the Lagrange multiplier rho, you can solve this for the allocation pointwise. For any vector of values and costs, you can either have trade or not to maximize this expression. Okay, so solving for the allocation rule for any given value of rho is trivial. And then the optimal allocation rule will be the one associated with the smallest value of the Lagrange multiplier such that the no deficit constraint is satisfied. And it's the feasible values are going to be rho bigger than or equal to the maximum bargaining weight. So it'll be the smallest rho bigger than or equal to the maximum bargaining weight such that you have no deficit. Right, so this is going to be tractable, implementable mechanism if we're thinking about incomplete information bargaining. And we're going to get a number of results. We can understand what this is. Here, let script M be the set of ICIR no deficit mechanisms. Then the incomplete information bargaining payoffs from the mechanism I just talked about, they coincide with the Pareto undominated payoffs for M. And the proof of that is pretty straightforward. Given a mechanism in script M with Pareto undominated payoffs U, we can construct weights that we would use in our incomplete information bargaining mechanism from the Lagrange multipliers on the constraints that other agents' payoffs are at least as great as in the vector U. And no money is left on the table in our mechanism, so any bargaining outcome is going to be Pareto undominated. In addition, under incomplete information bargaining, we have the result that equalization of bargaining power weakly increases expected social surplus, and strictly so, with few exceptions. The frontier of joint buyer and joint supplier payoffs is concave, just like as we were looking at with the K-double auction. And social surplus increases with equalization of bargaining weights, which is consistent with the arguments being made in antitrust circles regarding the merchants and the payment cards and doctors versus insurance companies. Okay, I'm going to apply this first to mergers and horizontal mergers and vertical mergers. I talk about investment. Any questions before I talk about these applications? Okay. In order to talk about a merger, so a merger between two suppliers or two buyers here, we need to think about exactly how we're going to model that merger. So let's consider a merger of suppliers, so merger of suppliers I and J, and let's take the case where we're merging two suppliers that each individually would be able to supply all of the demand on the demand side of the market. And let's model the merged entity as then having a constant marginal value for being able to produce that many units, the same KB units, but it'll be drawn from a different distribution. It'll be drawn from the distribution of the minimum of a cost drawn from supplier I's distribution and a cost drawn from supplier J's distribution. And so this GIJ here is just the formula for the distribution of the minimum of two cost draws from those two distributions. And this will be kind of the normal way that people have modeled mergers in this setting. It encompasses the usual assumption that you would have with single unit agents that a merged bidder's cost is the minimum of the costs of the two merging bidders. And we'll say that a merger does not alter bargaining weights if the two pre-merger firms have the same bargaining weight and that the merged entity also inherits that bargaining weight and that all others are unchanged. And then we have the result that a horizontal merger of suppliers that can each serve the whole market that doesn't alter bargaining weights weakly reduces expected weighted welfare. So mergers are bad, as we might have expected for expected weighted welfare, and strictly so if the merged entity has less than the maximum bargaining weight and with equality for all agents, so no effect for any agent if it's the case that the two merging suppliers had all the bargaining weight in the first place and everyone else had no bargaining weight. So if the mechanism was maximizing the joint surplus of the merging suppliers pre-merger, then there's going to be no effect of a merger. This gives us a number of results. If you take a merger of symmetric agents, that's going to weakly reduce expected social surplus in line with the usual expectation about effects of a merger. It's going to harm a non-merging agent that has all the bargaining power and the incentive for two agents with all the bargaining. There's no incentive for two agents with all the bargaining power to merge. And more generally in the paper, we provide conditions on this distribution for the merged entity such that the merger will reduce expected weighted welfare.
So
sorry.
Go ahead, Antonio.
Go ahead.
No, you first.
Go ahead. Okay. I have one
question, and depending on how you answer it, a comment. Are we implicitly assuming here that these firms are competing in quantity, or it doesn't matter? It's super general, and are they homogeneous, non-homogeneous products? All of these qualifications don't matter, or is some implicit assumption here?
We're not making the nature of competition here. There's a price formation process that is the mechanism that is going to determine how much each agent trades, and the profits that they receive is going to be this mechanism that maximizes expected weighted welfare, subject to ICIR and no deficit. So it's not taking a stand on whether that is price competition or quantity competition.
But the goods are homogeneous that different suppliers supply, or no?
Here they're homogeneous, yes. You can be more general and have buyers, for example, have a preference over the supplier's products, as long as suppose you have a multiplicative parameter that's my preference or my quality of weight on the different suppliers' products. If that parameter is common knowledge, then this is fine. You can allow that kind of differentiation.
Okay, and if you can go back to the previous proposition, that is the comment that I had. So we already know from a bunch of papers in IO that if you are in a setup with homogeneous products, and with quantity competition, so that's a special case of one particular case of what you're looking at. Whenever we have horizontal merger that don't have efficiency gains, so where the resulting merged entity cost is at best equal to the minimum of the single firm's marginal cost, you're not going to have any, the merger is going to be welfare detrimental. So what are you adding to that result here in terms of, you see what I mean? Like the welfare conclusion is the same. The assumption on the efficiency gains or lack thereof is the same, but you're doing it with multiple buyer, multiple seller on each side. So how does your result compare to the obvious or the well-known one?
Good, yeah. So first of all, when you talk about quantity competition, typically we have in mind a setting where you have some number of suppliers engaged in maybe Cornell competition, and then the buyer side of the market would be price-taking consumers, would be a demand curve. And so this is going to allow us to talk about bargaining power on both sides of the market. In the usual Cornell setup, it's hard to think what it would mean to have buyer power in that market. You've got price-taking consumers. So it's going to allow us to talk about equalization of bargaining power, differential bargaining power, different sides of the market, that in a way that I'm not sure how you would approach that in the typical oligopoly model, where you have price-taking consumers. I found it comforting, just that we're getting, there's nothing crazy here. You can identify settings where a horizontal merger is going to reduce social surplus. So, and then with that grounding, we're going to be able to do all kinds of things that you wouldn't.
Yeah. So the outcome, I wasn't undermining the whole framework. Just for this result, that's why I asked you to go back. Just this result, there is nothing more so far yet compared to the result that you obtain with the price-taking consumers in Cornell, right?
I think there's a little bit more to it here, in that we're doing it in a setup with bargaining power on both sides of the market. But you're right that we're not going to get super excited just on the result that mergers are bad.
Okay.
Yeah.
Thanks.
Well, so I mean, I would probably say that Antonio's point is spot on in the sense that if you don't have bargaining power effects of a merger, then we get that that negative result that you would have in the standard model. So in that case, for that case, our model resonates with what you know from the literature. But maybe you need to take that offline.
Okay, good. So now we're going to talk about buyer power. So something that you typically wouldn't easily talk about in the usual oligopoly setup. And we see that buyer power is going to exacerbate merger harm. Okay, so consider our same setup with horizontal merger of suppliers. Then if the pre-merger market is efficient, the merger is going to reduce social surplus strictly, unless the merging suppliers have the maximum bargaining weight. And if the pre-merger market is efficient, then a merger of symmetric suppliers is going to reduce social surplus by more if the buyers have all the bargaining power than if the merging suppliers have all the bargaining power. So there's a sense in which a horizontal merger among suppliers is worse, more harmful in a setup with bargaining power, with buyer power. And nonetheless, antitrust authorities tend to view supplier mergers more favorably when the buyers are powerful. There's a whole section on the US horizontal merger guidelines on powerful buyers and how that can alleviate potential harms. So let's try to explore that a bit more. So this graph is the frontier. Total supplier surplus on the horizontal axis and total buyer surplus on the vertical axis for the case where you have one buyer and two pre-merger suppliers. So it's not symmetric like the one we saw before, because I've got one buyer and two suppliers in this graph. And then we can map out our frontier by varying the differential between buyer side and supplier bargaining weights. So delta equal to 1 corresponds to the buyer having all the bargaining weight, delta equal to half is equal, and delta equal to 0 is the suppliers having all the bargaining weight. And now let's have a merger. So we'll let these two suppliers merge, and that's going to shift the frontier. It doesn't change when the suppliers have all the bargaining weight, because then the pre-merger mechanism was maximizing their joint payoff anyway. But you have an increasing harm from the merger as the bargaining weight increases. Okay, so you see the shift down in the total surplus as a result of the merger for any given delta. Well, if we want to think about these mergers with buyer power, suppose that in the pre-merger market, the buyers had all the power. Then the merger is going to shift from the blue delta equals 1 dot to the orange one. But then it may also be that as you move from a market where you have a buyer negotiating with two suppliers, where the buyer has all the bargaining power, and you shift that to a market where you have one buyer and one supplier, you may at that point have more equal bargaining weights. If you do have a shift in bargaining weights here to delta equal to a half, you can see that the post-merger social surplus is actually greater than social surplus before the merger. So this,
Leslie, given the importance of the bargaining weights that this result sort of conveys, but you're taking, so the model takes them as exogenous, right? So
right.
There's nothing in the model that allows you to endogenously shift the bargaining weights. And the other question that I had that I couldn't ask, given your discussion with Antonio, so the results that you had are just for merger of suppliers that have equal bargaining weights. Do you have results for when merger occurs with when suppliers don't have equal bargaining weights?
We haven't tried to generate any kind of general results. You'd have to make an assumption then about what the bargaining weight is of the merged entity. And so, yeah, I suppose we could look, I mean, we could suppose that the merged entity inherits the lower bargaining weight, or suppose it inherits the larger bargaining weight, and go from there. But we haven't tried to get general results for that case.
So that seems really, interesting, right? So
yeah, we can do that. Good point.
So I think it is true that in order to be on the frontier, the bargaining weights by the sellers have to be the same and the bargaining weights by the buyers, right? So whenever a merger induces an equalization of bargaining weights on the supply side, that will get you closer to or onto the frontier. So that would be a good thing to happen.
Good, yeah. So just to summarize these results on countervailing power shifts in bargaining power, a merger combined with an equalization of bargaining weights between the buyer and seller sides of the market is no more harmful to expected social surplus than the same merger with no change in bargaining weights, and in some settings increases expected social surplus, including sometimes to the first best. So this points to the relevance of allowing the possibility that a merger changes the price formation process, changes the bargaining weights. There's some empirical evidence. Degroulas and Rovagati show that consolidation, mergers among online advertising intermediaries, increased their bargaining power vis-a-vis Google, reducing Google's revenue from online search, and suggests a double-edged sword of allowing supplier mergers with powerful buyers, which the antitrust authorities seem predisposed to allow, because when you have powerful buyers, there is the possibility of post-merger equalization of bargaining weights that could be good for social surplus. But if that equalization doesn't occur, then those are the mergers that are going to be most harmful for social surplus. I'm going to skip this. I'm going to skip those and just go to vertical integration. I'm a little worried about that time. So let me talk about vertical integration. Vertical integration has gotten a lot of attention lately. I think it was getting more attention, and that spurred the update to the vertical merger guidelines, and that has also spurred additional work. Vertical integration is traditionally viewed favorably. It eliminates double marginalization. The positive view of it carried the day in the AT&T Time Warner merger, which was vertical and was allowed to go through despite objections from the DOJ. But that ignores potential adverse efficiency effects on the bargaining process, which we can look at in our incomplete information framework. So to model a vertical merger or vertical integration, let's assume that buyer one vertically integrates with supplier one, and that the integrated firm has no agency problem or can resolve it efficiently. And then so we can get some clean results, let's restrict attention to the case of single unit demand and supply, and we'll focus on either a one-to-one or one-to-many setup. So we've got either one buyer and lots of suppliers, or one supplier and lots of buyers. So for example, in the case with one buyer and many suppliers, when that one buyer integrates with one of the suppliers, that integrated firm might want to purchase its input from one of the outside suppliers. They might want to supply internally, or they might want to purchase from one of the external suppliers. The integrated firm's willingness to pay for an external unit is the minimum of the integrated buyer's willingness to pay and the cost that the internal supplier could produce that at. So it's the minimum of V1 and C1. We can quickly get a couple results. First, if the supports overlap, buyer and supplier distribution supports overlap, then vertical integration increases social surplus when the number of agents is sufficiently small, regardless of bargaining weights. And the proof is straightforward. If you take just a one-to-one market, then we know that in the pre-merger market, we don't have efficient trade by the Myerson-Satterthwaite result, and vertical integration is going to resolve that. So for the one-to-one market, vertical integration is going to resolve the Myerson-Satterthwaite problem. But if we have the kind of non-overlapping case, so consider a one-to-many pre-integration market with one buyer, multiple suppliers, and if C upper bar is less than V upper bar, so that having non-overlapping supports is going to be possible, And if V lower bar is sufficiently large, then vertical integration decreases social surplus whenever pre-integration bargaining weights are symmetric, regardless of post-integration bargaining weights. And the proof again is easy. If you have V lower bar bigger than C upper bar, that's the case of non-overlapping supports, and vertical integration creates a Myerson-Sadig weight problem. In the pre-integration market, you have non-overlapping supports, you can get efficiency. But post-integration, that integrated firm, its willingness to pay for an external unit is the minimum of the buyer's value and the supplier's cost. And in this case with non-overlapping supports, that's the supplier's cost is the minimum. And so its willingness to pay now is drawn from the same support as the external suppliers. And what goes wrong, the inefficiency comes from the fact that that integrated firm is sometimes going to source internally, even though an independent supplier has a lower cost. The social benefit, so we have our vertical integration can either harm or help social surplus, can either create or resolve a Myerson-Sadig weight problem. The social benefit from vertical integration is going to be reduced when gains from trade are more certain. So when gains from trade without integration are more certain, then the value of vertical integration resolving that internal trading issue are reduced. And you can show that formally in that the maximum gain from vertical integration, the welfare under the first best minus the welfare under the second best scaled by the first best welfare is going to be decreasing in V lower bar whenever that's positive. Returning to overlapping supports, with overlapping supports and one-to-many trade, vertical integration is going to eliminate a double markup. So it's going to eliminate the information rent within the integrated firm, but it also makes the outside market less competitive. It removes a supplier from the outside market and possibly less efficient. There's an intuition based on oligopoly models that suggests that vertical integration is particularly harmful in an otherwise highly competitive market. And that kind of comes through in our setup. So if you take uniform types and look at the social surplus effects of vertical integration, the change in social surplus as a result of vertical integration as a function of the number of outside suppliers, you see that it's positive for small numbers of outside suppliers and then negative and then approaches zero from below as n grows large. So the social surplus effects of vertical integration are, again, particularly harmful in otherwise highly competitive markets. The vertical integration that I've talked about here has had one-to-one or one-to-many trade. There are interesting and challenging and still open issues when you look at vertical integration in a many-to-many setting. And so let me just give a few hints at issues there. In a many-to-many setting, suppose you have many buyers and many suppliers, then when one buyer and one supplier vertically integrate, that integrated firm might either be a buyer or a supplier vis-a-vis the outside firms in the post-integration market, or might not trade at all. So that means that the trading position of this vertically integrated firm, whether to buy or sell or not trade, is going to be endogenous. And unless the vertically integrated firm has all the bargaining weight, its relevant virtual type is going to be the virtual cost for some type realizations and the virtual value for other type realizations. And that's necessarily not monotone and so requires ironing. So there are additional challenges in that setup. And there are modeling challenges to stay within the Myersonian framework with single dimensional types. We have some ideas on how you can resolve that by, for example, viewing the vertically integrated firm as having a maximum demand equal to the capacity of the integrated supplier plus the capacity of the integrated buyer with an endowment equal to the capacity of the integrated supplier. And then you can think of them as having a constant willingness to pay drawn from some distribution that's a mixture that we can work out of the pre-integration buyer and suppliers distributions. So challenges there going forward, but I think they're interesting problems and that we can make progress there as well. Good, let me talk a little bit about investment. Investment incentives feature prominently and controversially in concurrent debates, including, for example, the Dow-DuPont merger. Whereas it turns out countervailing power was also one of the issues raised in Europe. There's a central role in the theory of the firm in the Grossman-Hart-Moore tradition for investment, where Grossman-Hart-Moore assumed efficient, complete information bargaining, and this creates a holdup on investment. And we show that private information protects agents from holdup. Investments are efficient if bargaining is efficient, which gives us starkly different results than you get in the complete information law. So to see what's going on here, let's think of the agents as being able to make investments at some cost that affect their type distributions. And as in Grossman-Hart-Moore, let's assume that those investments are non-contractable. Then first best investments are going to be a Nash equilibrium outcome of a simultaneous investment gain if incomplete information bargaining is efficient. And to see the sketch of the proof there, the planner's first best investments are going to maximize expected first best welfare minus the agent's investment costs. And if bargaining is such that the first best is possible, it's going to be without loss of generality to focus on VCG payoffs, which mean an agent's payoff is its first best welfare up to terms that don't depend on the agent's type. So that means that each agent's individual maximization problem, their Nash equilibrium investment is going to maximize expected first best welfare minus their investment costs, which is the same maximization problem as for the planner. So we'll get efficient investment there. It's the same condition as for efficient investments as in Hatfield-Kojima commoners. And you can relate it to the paper by Lauerman, where you think of search in the Lauerman paper as being investment, with the difference that the no deficit constraint may preclude the first best. And under additional conditions, the converse is also true, where efficient investments imply efficient bargaining. And I think I'll leave that for now. Let me talk about one other thing related to on investment. We can look at some comparative statics on investment, and this exercise here is looking at how investment is affected by bargaining power. And this first graph is showing for the case of non-overlapping supports, where you're actually going to get first best investments when the bargaining rates are sufficiently equalized, and shows how investment becomes less efficient, moves away from the first best as you move away from equal bargaining weights. And notice that if you have the delta closer to 1, so your buyer has higher bargaining weight, the buyer has lower investment. The blue line comes below the orange line. So this is saying a buyer that has more bargaining power is going to have a lower equilibrium investment. So in a sense, there's a sense in which the bargaining power is substituting for investment in the buyer's problem. Less incentive to make these investments when you have the bargaining power. And then as you have partially overlapping supports here, then you no longer have efficient bargaining. And so we know that you're no longer going to get efficient investment. So it pulls away from the first best frontier in that case. We can put together now these ideas about vertical integration with the ideas about investment. And we see that for bilateral trade and overlapping supports, investments will be efficient if and only if there is vertical integration. So in the overlapping supports case, we're only going to have efficient bargaining when you have vertical integration. So in that case, vertical integration promotes efficient investment. And in contrast, If, for example, you have one buyer and two suppliers and non-overlapping supports, investments are going to be efficient without, but not with, vertical integration. So that's a case where vertical integration is going to disrupt efficient investment. There's quite a bit of related literature. The references in the paper go on and on for pages. Private information is recognized as an obstacle to achieve efficient outcomes. We've talked about a number of those papers. As we show here, the Myersonian IPV setup provides a tractable model and methodology. It's assuming risk-neutral buyers and suppliers, independent one-dimensional continuous private information, and incentive-compatible, individually rational, deficit-free mechanisms. These are sufficient to generate the profit efficiency trade-off in a tractable and disciplined way. But it's also the case that they are, in a sense, the unique known assumptions that do so, and so they are themselves not arbitrary. I want to highlight this Larson and Zhang paper. There's a sense in which it is the empirical counterpart to our approach. So we take this as if approach to incomplete information bargaining. They are looking at data and making only the assumption that this bargaining data comes from some incentive compatible mechanism. And the implications of incentive compatibility tell you that the price menu has to be convex. And using that, they're able to back out from the data the distributions, the underlying distributions of the bargaining parties. Once you have the distributions, you now can construct the Pareto frontier and use that and observe outcomes to identify bargaining rates, identify where you are on the frontier. So the Larson-Zhang approach gives you a way that given data, you can identify, given incomplete information bargaining data, you can identify both the underlying distributions and the associated bargaining rates. There's also a large literature on countervailing buyer power, countervailing power and buyer power, vertical integration and foreclosure, incentives for investment, and quite a lot of recent literature on bargaining and interest in countervailing power effects, how consolidation changes bargaining rates and changes the price formation process in these markets. Much of this focusing on Nash and Nash bargaining as the underlying model, so staying within the complete information world. But as we see, there are effects that are not going to come through in a complete information model where you don't have the trade-off, same trade-off between social surplus and rent extraction. So to conclude, the incomplete information setup here offers a nearly ideal framework for IO economists concerned with the trade-offs between social surplus and rent extraction, price formation and its efficiency properties, and the dependence of bargaining power on the bargaining power of agents. And in this setup, you naturally get social surplus increasing countervailing power and socially harmful vertical integration. In addition, you get a relation between incentives to invest and the efficiency of price formation that differs starkly from complete information models. For future research, I think it would be interesting and important to be able to say something about raising rivals cost arguments as a result of vertical integration. So that we need to move to a many-to-many environment. And as questions highlighted, thinking more about what exactly determines bargaining power, our setup highlights that it can be independent of prices and distributions and is reflected in the process, the price formation process itself, not just the level of prices. That's all I have. Thank you.
So let's thank Leslie before we go to questions.
And maybe also let's stop the recording, Juan Carlos, so that people can feel more comfortable discussing.
Let's do so.